Okay, this is just a quick overview of what continuity means. So continuity and continuous is the same thing. Continuity means there's a smooth, consistent line going or graph going through. There's no breaks or jumps or holes or anything like that. So I drew 3 different graphs. We're talking about when x is approaching 3. Okay, so if you notice on this one, you can see that I don't really care. I could have a hole. I could have a hole over here, or a hole here and a point here. All I care about is what is going on right here. Okay, we're looking at a very specific point in on our graph. So all I want to do is find the limit as x approaches 3, and again, no plus or minus, so I'm coming from the same, from both sides, coming in from both sides. So I'm coming in, graphically I'm looking, I can see that there's no holes or jumps or anything right here. So my graph, we'll call this 4. I'll just do it on each of these. On this one, my function is continuous at 3. Continuous at x equals 3. So there's no holes, no jumps. When I follow my graph, both fingers come together at y equals 4. Okay, so this is a continuous. There's no holes or jumps right out here. Now, if I asked you for when x is 1, right, if x was 1, I am still coming in and I'm still approaching this value, this y value. So this one, the limit does exist there, but it's not continuous because there's a hole there. Okay, so look at this one. The limit as x approaches 3 of my function, okay, still, even though there's a hole there, the limit does exist, right? My fingers are coming together at y equals 4. But there's a hole there. That means it's a jump. If I were to have this pen and I'm following it along, in order to get past this hole, I have to jump. I have to lift my pencil off the board and then continue. So this is what's called discontinuous. Discontinuous at x equals 3. Because there's a hole there. Okay? This one, my limit does exist, right? It does exist. It's not continuous because, again, I have to jump up here and then jump back down. And I have a point here, but not a point here. So this is also discontinuous at x equals 3. But it does not mean that the limit doesn't exist, because my fingers do come together at that value, at that open hole, okay? Now, to have continuity, you have to have 3 things happen. There's 3 characteristics of a continuous function. So the first one, let me get a different pen that actually is dark enough. So the first one is the limit of x approaching c, some value of the function, exists. Okay, so with all 3 of these, the limit does exist, right? It exists here at 3, it exists here at 3, it also exists here at 3. So that all 3 of these pass this first criteria, okay, to have continuity. The second one is f of c exists. Okay, so remember, this is our algebra question. What's happening at whatever that constant is. So here, I do have a value at 3. It's this value right here. This one, I do not. Okay, so this one fails this f of c exists because there is no value at x is 3. Okay, this one, there is a value that exists. All right, so it passes both of them. The limit exists, and there is a value that at x is 3. So this one, it passes the first 2. Now we have to have the third criteria. The third criteria says that the limit as x approaches c of my function is the same thing as the actual point. Okay? So this one, I have a limit, I have a value that does exist, and the value that exists is the same as my limit. So this one, that's why it's continuous. It has to pass all three criteria. This one, I have a limit, but it fails because at x is 3, there's no value there. Okay, so it failed that one. So this one failed the second criteria. Okay? With this one, I have a limit exists, right? My fingers come together at x equals 3. I do have a value that exists, but my limit and the value are two different things. So this one fails number 3. Okay, so that's a real quick overview of what continuity is. Continuity means you have to have all three of those criteria has to be covered. You could have 2 out of the 3, but at the minute it drops one of the, or fails one of the criteria, then it is no longer continuous. Okay, now the purpose and the reason why we have to have continuity is when we get into derivatives, our function has to be continuous at that point. You have to have something, some substance at that point that we're looking for the derivative. Okay?